Oh, hello everyone. My name is Emmanuel James. I want to explain the procedure involved in the construction of the isometric block shown below. It's an isometric projection, but what we observed there at the top left corner shown before is the orthographic projection in first angle projection. So we just have a very simple method of construction here, and everything that is being done here is practically every step in the construction method. What we're trying to do here now is to form the angle of construction for the isometric drawing, and the angle for construction is 30 degrees to the horizontal. The process shown below here is shown now. This is the bisection of the straight line. After bisection of the line, we're going to get 30 degrees. That is the 30 degrees to the left and to the right side. Faint lines are used as initial construction lines. Then after the whole construction is completed, then you can now use bold lines to show the details boldly. Repeat the dimensions as can be seen on the first angle orthographic projection and duplicate it right there on the drawing. In order for us to have straight lines, parallel lines, and to avoid the repetitive use of set squares at each corner, there is a simple method of just once we've gotten the first straight line, any of the lines can be moved by placing the set square parallel to it and then putting your ruler under, holding the ruler stiff. The lines can be duplicated easily, just as it can be seen now. First of all, you place the set square parallel to the line, put the ruler beneath, and then you slide to any part you want to put the line. Now I want to measure the 40 centimeter. As can be seen now, we've gotten the point, and then we move the line to that point in order to have a straight line. What we just measured now is the thickness of the first part. If we observe very well, we'll see a part where we mark as 7. That's the thickness of the face. Now everything that is being done is done with faint lines. We make sure the lines are not too bold, so that if there's any need for correction, we can correct it easily without having to make our work look very rough. Now the point that is just raised now, yes, that line is representing the part where we have 21 cm. 21 cm. So that's the face. You raise it and then we mark it on both sides. When you mark it on the other side and mark it over there, we know that 2 points will give us a straight line. So we join the 2 points together and make sure the lines are parallel. This method of construction using a set square and placing a ruler beneath it is a very simple one. We know we can use set squares of 30 degrees and 60 degrees and 45 degrees at respective locations or places or points. But in this case, once we've gotten the first line, we can as well just slide it to any point we want. Now, the point that is being noted now is 8 cm at the top. That is before the groove. That's the first 8 cm I have there. Now we mark the other part. All we know is that both the chamfered groove, just immediately after the top, the first part that slants downwards, that's the groove. If we are to draw a straight line, the measurement as seen from the plan is 8. So on the plan we have to mark 8. In fact, for the total length of the plan, we mark 8, 8, 8, 8, and 8. That is the chamfered groove. Each part is 8 cm. Looking at it from the plan, it is in the process of construction that we have to actually measure the point where we have the groove and then indicate the length of that groove, as can be seen in the diagram. That's the front elevation. And that's what we're doing now. So I'm just trying to make this as easy as it can be. Though the lines may not be too clearly seen, but if we follow through, we would understand the process of construction. That's what we're just measuring now. That is the depth of the groove of the chamfered part. That's the depth of the chamfered part. So from there now we have to join it to the first part. We're about to measure the second part of the chamfered groove now, and then we join it to the other side. The next thing now is to get the depth of the rectangular part. After the groove, we have a part that goes inside, so we have to measure the depth as can be seen on the front elevation there. Yes, that is the depth of the rectangular part.
Exclusive at NigerPhoenix.com.
We're almost done. What is remaining now is the back side, and what we're going to do is to replicate the details we have on the front to the same thing we have, and it's going to be the same thing we should have at the back side as well. For example, we see from the plan that the first part there will have 18, so that's what we are taking from the front now to mark at the back. That's 18 to have 2 points, so we can get a straight line. We join them together. Then the base, we pick the points from the base and also replicate it at the back side. In order to have 2 points, we stretch a line downwards. We still mark it there just to have a straight line. We're almost done. Now the back. We have to have a line going from that side towards the other end. Same direction. So we pick one of the lines there and then just move it. We're moving the line, the set square and the rule. We pick one closer and then we move it to that end so we can easily draw a straight line. So with this now, the drawing is complete. So I want to make the details bold. We'll make the details very bold so it's going to come out very clear. Make the lines bold. I try to explain the reason why I use the faint lines first. It's very essential. Construction details must be seen. It shows the process of construction, and it also helps in the correction of any wrong line that is being drawn. If I observe that the line is not in order and then I've already used bold lines, it will be difficult to wipe off, and even if you wipe it off, it will make the work look a bit rough. So we use faint lines first for the construction details, and then at the end we make the lines bold. In engineering drawings, it is true that we have we use different pencils to indicate the construction lines and the rest. But now we're using HB pencil for both the construction line and the bold line. But in practice and for study purposes, we have different pencils for different construction lines. So having done it thus far, every details have been clearly outlined and the work is clear. So that's what we have up there. At the top left, we have it in the first angle orthographic projection. Now we are able to transcribe it into an isometric projection where we can see all the views at the same time, the front, the plan, and the end elevation. Thanks for watching.